In today's session, we will be discussing about behavioral models. Behavioral models are the models that represents the dynamic behavior of system as it is executing. So they shows what happens or what is supposed to happen when a system responds to a stimulus from its environment. So these stimulus can be of two types. Either they can be data stimulus or it can be event stimulus. Data is a data stimuli is that is some data arrives that has to be processed by the system. So then events in the sense event stimuli is it may be some events that triggers the system processing. So if these kinds of stimuli can exist in the dynamic nature of a dynamic behavior of a system. Now we shall see the example diagrams for these stimuli. First is data-driven modeling. Data-driven modeling shows the sequence of actions involved in processing the input data and generating an associated output. Here, you need not to explain the processing steps. I have not explained the processing steps. The thing here is you have to observe the messages are sent only from left to right. Here you can see the messages are sent only from left to right. So in the sense, it shows the sequential data processing in the system. It shows that the messages which are sent from left to right shows the sequential data processing in the system. Here it shows the activities involved between the purchase officer and a supplier while placing an order, which is a sequential data processing in the system. So data driven modeling, it shows the sequence of actions involved in processing the input data and generating the its associated output. The thing here you have to observe is the messages are sent from left to right. It means it shows the sequential data processing in the system. Then it shows the activities which are involved between the purchase officer and the supplier while placing the order. So it is a sequential data processing in the system. Next, we will move on to event-driven modeling. Event-driven modeling shows how a system responds to external and internal events. It is done based on the assumption that the system has a finite number of states and events. Here events are nothing but stimuli. So these events causes the transition from one state to the another. They have taken an example of microwave open system and shows us the state diagram for that. This state diagram shows system states and the events that causes the transition from one state to the another. Here an example of control software for a microwave oven is illustrated in this figure. So in the UML state diagram, the rounded rectangles, you can observe here, there are different rounded rectangles. There are many rounded rectangles are there. So these rounded rectangles are the system states. They may include a brief description of a do action. You can observe here a do action is there. So these rectangles, that is rounded rectangles, are the system states which are having a brief descriptions of a do action. Next, you can observe labeled arrows. Here you can see full power, off power, timer. So these are all the labeled arrows. These are the stimuli that force the transition. So these are the stimuli that forces the transition to occur. Next, fillet circle. Fillet circle is it is indicating the start of the state. It indicates the start state. And next, a fillet circle inside a circle, it is a end state. Fillet circle is a start state, whereas fillet circle within a inside a circle is a end state. Next, we will move on to the microwave operation. So for now we got to know the states of the how the states are represented, what are the stimuli, how they are represented in the state diagram, and we get to know how to represent the start state and how to represent the end state. Now we will move on to the microwave operation, microwave oven operation. The figure shows the microwave oven operation. The operation includes a number of steps, substates. Here, operation is in state, so it includes number of substates within that. This figure shows operation starts with a status check. So this shows the operation starts with a status check. If any problems are identified, an alarm is indicated. First, it will check the status of the oven, and if everything is fine, then an alarm is if everything is fine, it moves to the further. If any problems are identified, then an alarm is indicated and then operation is disabled. It will move to the disabled state. You can see the different parts. So if it is having turntable fault or it is having an emitter fault, then an alarm will be indicated. Then once the alarm is indicated, the operation will be disabled. Then if everything is fine, it moves to the cooking state. That is, when it checks the status, if everything is fine, then it moves to the cooking state. So cooking state involves running the generator for a specified time. So here you can see do action run generator. So it involves, that is the cooking state involves running the generator for a specified time. Time is the input here. So you can see an arrow. So it is an input, that is time is the input here. Once cooking completed, a buzzer sound is made for 5 seconds. So once cooking completed, a buzzer will sound for 5 seconds. Then if the door is opened during the operation, if the door is opened during the operation, it will move to the disabled state. That is, the system moves to the disabled state. So this is how microwave operation can be explained. So till now we came to know what is behavioral model and what is data driven modeling and what is event driven modeling, how to represent the event driven modeling, and for that we have taken an example of a state diagram of a microwave oven, and microwave oven operation is also explained. Then in later classes we shall see the other models. Thank you.